Hi. So last time we started to talk about, in general, ions, cations, and anions, and how and why they form. And now what we're really looking at is ions in compounds. So how do ionic compounds form, and what holds them together? And what holds an ionic compound together is what we call an ionic bond. You can see the definition there, the attraction between the negative and positive ions. So an ionic compound is made of ions, negative and positive, and they are attracted to each other. And they form what we will come to know as a crystal lattice. If you can see on the right side here, all of those purple and green spheres representing the negative and positive ions come together in a 3D geometric kind of checkerboard pattern. And that is what, if you were to zoom in on a little grain of salt, this is what it would look like. The next graphic shows just a whole bunch of different representations of forming an ionic compound, specifically sodium chloride. And as you can see just from the chemical equation, you have neutral sodium and chlorine, and then forming positive sodium and negative chloride. And you will also see that all of these will release energy. Forming ionic compounds is exothermic, meaning energy is released, because you're taking atoms that are unstable, that they don't have a full octet, and they're becoming atoms that are ions, that are very stable because they do have a full octet. So as we go down the graphic here, you can look at their electron configurations and see how sodium, here's sodium's valence electron, and it gets transferred to chlorine. Now chlorine has the same electron configuration as argon, a noble gas, and sodium, because it loses one electron, now has the same electron configuration of neon, which is also a noble gas. Here's the the orbital diagram, and you can see sodium's valence electron getting transferred, making a full outermost energy level. That full octet is very stable. You'll see the same things as what we were looking at in the beginning of the chapter with these electron dot diagrams, and even these with their atomic model. So you can see that sodium has 11 on the beginning as it starts. At the end, it has 10 because it has one more proton in it than it is positive. So the big rule that is going to dictate how these ionic compounds form is that they will always transfer electrons so that both atoms become ions with a full outermost energy level, because that is stable. And that's the goal of all of the atoms. So let's look a little bit more at ionic bonding. Right? So first of all, what is an ion? And we've gone over this a few times. Atoms are, we don't like to say normally, but with the definition of an atom is that it is electrically neutral, meaning that it has the same number of protons and electrons. And an ion is an atom that has lost or gained an electron. If it has lost an electron, it is positive. If it has gained electron, it is negative. And so what is ionic bonding, or how is this related to ionic bonding? So ionic bonding occurs when a metal, the metal will always be the one to give up or donate one or more electrons. And it will donate that to a nonmetal. The nonmetal will gain. So the metal, because it loses an electron, becomes more positive, which we call a cation, and the nonmetal becomes more negative, and we call that now an anion. And here is that process just shown a little bit more symbolically or graphically with those Bohr model electron energy level rings, right? The sodium atom always starts, we know this from its electron configuration, it has one outermost valence electron, while chlorine has 7. You can see I drew that in as a red electron, just a red dot, because that's the one it's going to lose, right? You can see that what happens is it gets transferred. So here it is over on the right-hand side. At the beginning of this, you can see the little frowny face, right? When sodium has 1 valence electron and chlorine has 7, right? Neither atom is stable. That's why we get like the little frowny face. Now the electron gets transferred from the sodium to the chlorine. You can see now the sodium is a cation and the chlorine is an anion. You can see how the charges have changed, right? What happens is sodium donates its outer electron to the chlorine atom, and now both are stable. Sodium now has a new valence energy level. Over before, right, that third energy level was its valence energy level. Now it has no electrons in that third energy level. So its second energy level becomes its valence energy level. So its valence energy level is full. The chlorine valence energy level is full. We have a positive attracting to a negative, and that is what forms the compound, right? Now the ions have opposite charges and they attract each other. And this is a perfect match. That's the little heart eyes, right? They come together perfectly. Sodium gives one, chlorine gains one. Both are stable, both have a full outermost energy level. Now, does it always work exactly that perfectly, where one loses and another gains exactly one electron? Well, no, right? The sodium will always lose one electron to be most stable. Chlorine will always gain one to be most stable. But what if we have a combination of magnesium and chlorine? If you look at where magnesium is on the periodic table, it has 2 valence electrons. Therefore, magnesium will always form a 2+ ion, meaning it will need to give away 2 electrons. Well, if it's forming with chlorine, it gives 1 electron to one chlorine and another electron to another chlorine. It isn't going to give both electrons to one chlorine, because then chlorine would have a 2 negative charge and then wouldn't have a full outermost energy level. That's why it's so important to understand that they need to form, both atoms will form a full outermost energy level. They won't always combine in a 1-to-1 ratio. In fact, most of the time they won't combine in a 1-to-1 ratio. So you can see magnesium will give 2 electrons. It will give 1 to one chlorine, 1 to another chlorine. So the formula for the compound formed by magnesium and chlorine, magnesium chloride, as we're going to call it, is MgCl2. That subscript 2 stands for the 2 different chloride ions that need to be paired with 1 magnesium. Sometimes it does work out, even if it's not 1+ and 1- ions, that all you need is 1. So calcium also will form a 2+ ion because it has 2 valence electrons. Oxygen will form a 2- ion to be stable. It needs to gain 2 electrons. So this is sort of another perfect match where calcium will give the oxygen 1 electron and then the same oxygen another electron. So you will have 2 ions here that are perfectly matched, that are completely full outermost energy level, and all we needed was 1 chlorine and 1 oxygen. Chlorine gave 2, oxygen took 2. And so what we call, or what is being formed here, is called a formula unit. That is the definition of a formula unit, is the simplest whole number ratio of ions in an ionic compound. It is analogous to the word molecule with covalent compounds. So instead of saying, or if I was going to say a molecule of water, I might say the formula unit, or a formula unit of salt is NaCl. What is the simplest formula for it? Because remember, if I have salt, I never actually have 1 Na+ and 1 Cl-. That's the ratio of them. But if I have a grain of salt, I might have billions and trillions of sodium and chlorine or chloride ions. That's what this picture over here is showing, that it's in this 3D crystal lattice array type scenario where there's many of them. So the formula unit is the smallest or the lowest whole number ratio. We would go back and say the formula unit for the compound formed between magnesium and chlorine is that MgCl2. The formula unit for the compound calcium oxide is CaO. So what we're going to do now is one of the most important things that we will do all year, and that's writing the formula units for these particular ionic compounds. So the first thing that we do is we write the ions formed and then the ionic compound that must be formed from them. So we already did this. Sodium will form a +1 ion and chlorine will form a -1 ion. So how will those two combine so that the lasting compound is neutral, so that the same number of electrons lost is the same as the number of electrons gained? And it's pretty simple, right? We looked at this before. All you need is one of each. Well, what about sodium and oxygen? This is telling me that each sodium will lose 1 electron, but oxygen needs to gain 2. So in order for this to work out, I'm actually going to need, right, 2 sodium, because each sodium is going to lose 1, and therefore 1 oxygen will gain them. So now the subscripts are the number, how many of that ion were needed to become neutral, right? Magnesium will form a 2+ ion. Chlorine will form a negative ion. Now inside that box, I need it to be neutral. I need the same number of positive as negative. How do I do that? Well, with, of course, 2 chlorines. Now I have 2 positives and 2 negatives. That means 2 electrons were lost and 2 electrons were gained. So the formula for this guy is MgCl2, right? Because this subscript stands for how many. There were 2 chlorines, so it has a subscript of 2. There were 2 sodiums, so it has a subscript of 2. Magnesium and magnesium and nitrogen. This one is tricky. Magnesium will form a 2+. Nitrogen, look on the periodic table, that forms a 3-. So I need to add more positive, but if I have 2 magnesium, now I have more positive than negative. So add another negative. Now I have more negative than positive. But if I add 1 more positive, look at what the positive charge is here, 6 positive. Look what the negative charge is here, 6 negative. That's exactly what I want. I want the same number of positive as negative. So now remember, the subscripts are how many. So how many magnesium did I need? 3. How many nitrogen did I need? 2. Mg3N2. And calcium, 2+, oxygen, 2-. Right there, with just 1 of each, I have a neutral compound. Now there's a little trick to this that I want to show you. That if I take these 2 ions and I take the number that's associated with the charge. So what is the number here? The number is 1. And I bring that down as the subscript. And what's the number here? It's a 1. And I bring that down as the subscript. I actually get the formula unit. And that happens all the time. We call it crisscrossing. That if I take, let's just look in the red, Na +1, O2 negative. Take this number 1 and bring it down here. Take this number 2 and bring it down here. Just the number, not the symbol. Then you get exactly what we have, Na2O. Right? Just Mg2+, Cl-, just the number, MgCl2. Mg2+, N3-, crisscross, just the number, Mg3N2. This would be the exception to that little trick, because they only, if I do my little trick with that, I would get Ca2O2. Remember what a formula unit is. The formula unit is the lowest whole number ratio. So if you could reduce them, if they're both even or they're both divisible by 3, then you should. And that's how I can get to CaO. We will do lots of practice with these, but remember the whole point is that we need a neutral compound at the end. So we need the same number of positive charge as negative charge in the compound.